There is a place in northern Canada where the government does not want you to go. Not because it is dangerous in the way that cliffs are dangerous, or rivers in late thaw when the ice turns gray and groans under your feet, and every step becomes a negotiation between forward momentum and the physics of cold water. Not because of unstable ground or toxic air or any of the standard practical reasons that authorities usually cite when they close something off and nail a sign to a post and hope that the sign is enough. Those reasons exist here too, technically. They are listed in the official documentation filed in Ottawa in language that sounds thorough and responsible and does not quite tell you anything. But they are not the real reason. The real reason is what was found inside. In the winter of 2003, a small team of researchers working under a government contract made their way into a cave system in the remote Northwest Territories, a region so far from anything most Canadians would call civilization that the nearest community was accessible only by bush plane, or, in deep winter, a grueling overland route that experienced guides still approach with the kind of caution that comes from first-hand knowledge of what the land can do when you underestimate it. The team was not looking for anything extraordinary. They were conducting a routine geological survey, the kind of quiet, unglamorous work that happens across the Canadian North every few years, producing reports that are filed and occasionally cited and rarely read by anyone outside a specific professional circle. They had their instruments, their cold weather gear, their emergency protocols, their detailed logs of daily observations. They had the particular professional detachment that develops over years of field work in demanding places. Not indifference, exactly, but a kind of calibrated focus that keeps attention on the task and does not waste energy on atmosphere. They found something that ended the routine. Within 72 hours of entering the cave, the lead researcher had placed an encrypted call to Ottawa. Within a week, the site was restricted under emergency provisions. Within a month, a formal closure order had been issued, citing, and this is the language that appears in the public-facing documentation, language chosen carefully enough to technically be accurate while communicating almost nothing, the need for further study and the preservation of fragile geological formations. The survey team was debriefed individually. The raw data was classified at a level that would keep most of it out of public view for years. 2 members of the original team have never spoken publicly about what they found in that cave. The other 3 have done so only in carefully mediated contexts, usually years after the fact, usually with significant portions of what they know still held back. But one of them spoke, carefully, incrementally, across several years of interviews and academic publications and one remarkably candid memoir piece published in a science communication journal. And what she described, what the evidence she collected described more precisely, because she is a scientist and she trusts the evidence over her own impressions, changed everything researchers thought they understood about how long human beings had been living in North America. This is not a story about a haunted cave. It is not a story about a government conspiracy in the sense that word usually implies when it appears in titles like this one. There are no classified alien artifacts here, no hidden military installations dug into the permafrost, no evidence of anything that could not be explained by the known and documented history of the Earth and the species that has spent the last few 100,000 years remaking it. What was found in that cave was far more unsettling than any of those things, because it was real, it was verifiable, it was subjected to some of the most rigorous scientific scrutiny available to the modern world, and it directly contradicted more than a century of accepted scientific understanding about the very first Canadians. It turns out the first Canadians were here a great deal earlier than anyone had been allowed to believe. This is the story of what was found, how it was found, what the institutions that are supposed to produce and protect knowledge did with it when they had it, what it means for the land and the people who have lived on it since before the word Canada existed, before the word continent existed, before any word that any language now spoken could describe, and what it means for every person who calls this country home, whether their family has been here for 20 years or 20,000. If this is the kind of history that makes you lean forward, subscribe right now. Hit the notification bell so you do not miss what comes next. This channel exists for the stories that do not make it into the standard curriculum, for the Canadian past that is stranger and older and more extraordinary than most people are ever told. We are just getting started. To understand why the cave mattered, you need to understand the landscape it sits inside, not just the geography, the rocks and the rivers, and the distance from anything, but the deeper character of the place. The Northwest Territories is not simply remote. It is something older than remoteness. It is the closest thing to deep geological time that most human beings will ever encounter while standing upright on the surface of the earth. The territory covers more than 1.3 million square kilometers. That number becomes meaningful only when you try to put it in context. It is larger than France, Germany, and Spain combined. It is larger than South Africa. It is larger than every American state except Alaska, and not by a little. Yet its permanent population is a little over 40,000 people, roughly the population of a mid-sized Canadian town, distributed across communities that are separated by distances that, in southern Canada, would represent hours of highway driving, and that here represent, in winter, a serious logistical undertaking, or, in spring when the ice roads melt, something close to isolation. The road network in the Northwest Territories is minimal in a way that most Canadians, accustomed to the dense highway infrastructure of the South, find difficult to process. There are paved roads connecting the capital, Yellowknife, to a handful of other communities, and to the southern provinces. There are ice roads, seasonal routes, over frozen lakes and rivers that are open for a few weeks in the deep cold of winter, and that carry the bulk of the supply traffic to communities that have no other surface connection to the rest of the country. And then there is everything else. River systems that serve as highways in summer for those who know them and have the boats. Air routes connecting communities that would otherwise be entirely cut off from each other. The overland routes that experienced hunters and guides travel on foot, or by snowmobile, reading a terrain that does not announce its paths, because it does not need to, because the people who know it carry the map in their bodies. This is the physical context. The geological context goes deeper. The bedrock of the Northwest Territories is among the oldest exposed rock on the surface of the planet. The Slave Craton, a massive section of ancient crust in the central and western part of the territory, contains formations that have been dated to more than 4 billion years. 4 billion years. The sun was younger then. The solar system was still assembling itself from the debris of its formation. The conditions that would eventually produce life on Earth were still being established, and the rock that is now the substrate of the Canadian North was already there, crystallizing out of conditions that nothing alive today has any analogy for. This rock has been here through everything, through every extinction event, every mass glaciation, every shift in the chemistry of the atmosphere, every rearrangement of the continents. It was here before there were eyes to see it. It is here now, under the boots of anyone who walks across it, patient in the way that only things measured in geological time can afford to be patient. The cave systems that have formed within certain limestone and dolomite formations across the territory are younger than this bedrock, geologically young, in the tens of thousands to hundreds of thousands of years range for most of the accessible ones. They form when slightly acidic water percolates through limestone, slowly dissolving the rock along fractures and bedding planes over timescales that dwarf human civilization while being relatively recent in the context of the rock itself. The result is a network of passages and chambers that can range from tight, uncomfortable crawlways to large open halls, depending on the specific geology and the duration of the dissolution process. These caves are cold. This is not incidental. The permafrost that underlies and surrounds many of them in the northern part of the territory acts as a thermal insulator and stabilizer, keeping interior temperatures close to or below freezing year-round, independent of the seasonal temperature swings that can see summer highs above 20 degrees Celsius and winter lows below -40. This thermal stability is what makes them so remarkable as archives of the past. Organic material decays, bones break down, charcoal disperses, plant remains rot, skin and hair and soft tissue dissolve back into the environment within years or decades in most conditions, leaving nothing but chemistry. In a warm, wet environment, the evidence of human presence can vanish almost completely within a few centuries. In a cold, dry, stable cave in the Canadian North, a cave where the temperature has barely fluctuated across tens of thousands of years, where the permafrost has kept moisture at bay and microbial activity suppressed, the evidence can survive for time scales that feel almost impossible. Bones stay intact. Charcoal remains recognizable. Organic material that would have crumbled to dust anywhere else holds together. The cold is a preservationist. The deep north is an archive of everything it has been too cold to destroy. This is why archaeologists and paleontologists have long understood that the caves of the Canadian North represent a potentially extraordinary opportunity. The problem, historically, has been that most of them are difficult and expensive to reach, that the survey work required to identify significant sites is slow and unglamorous and chronically underfunded, and that the vast majority of the territory remains, in a formal archaeological sense, barely examined. The cave that became known in the research literature as WR7 had never been formally surveyed before the winter of 2003. It had been known to the people who live in the region for generations, but no outside researcher had set foot inside it. No samples had been collected from it. No one from the formal institutions of Canadian science had spent a night in it and written down what they found. That changed on a cold morning in January 2003, when a government survey team loaded their equipment onto a bush plane and flew north. The cave system designated WR7 in the internal survey documentation. It has no official public name, and the exact location has not been made public, for reasons that will become clear, is situated in a remote section of what is broadly known as the Mackenzie Mountains Corridor, a region that straddles the boundary between the Northwest Territories and the Yukon. This is mountainous country, not the dramatic high-altitude peaks of the Rockies, but older, more eroded ranges, rounded by geological time and heavily glaciated, cut through by river valleys that carry snowmelt to the Mackenzie River and eventually to the Beaufort Sea. It is beautiful in the way that places without human infrastructure are sometimes beautiful. Not managed beauty, not beauty shaped to please a viewer, but beauty that exists independently of observation and does not require acknowledgement. The road access to this part of the territory is essentially non-existent. The nearest community with regular air service is several hundred kilometers away, accessible from the survey team's departure point by a flight that took just under 2 hours in the bush plane they chartered. The landing was on a frozen lake, a strip of cleared ice that had been used as a seasonal airstrip for decades, maintained by a combination of local knowledge and careful monitoring of ice thickness. The pilot knew the lake. He had landed on it before, and he checked the ice with the equipment he carried for that purpose, and he was satisfied, and he set the plane down with the particular controlled bump of a landing on a surface that is not designed to be a runway. The team that disembarked onto that frozen lake in January 2003 was 5 people. Dr. Elena Vasiliev was the lead researcher, a geologist holding a joint appointment with the Geological Survey of Canada and the University of Alberta. She was in her early 40s, with more than 15 years of field experience in the Canadian North, a publication record that was respected in her discipline, and a reputation for methodical, careful work. 2 field technicians, both men in their mid to late 30s, who had spent years doing this kind of work in the North, and who treated the backcountry with the particular matter-of-fact respect of people who have been genuinely frightened by it before, and have absorbed the lesson without drama. A junior researcher, a doctoral student completing field work that would eventually become part of a dissertation that was very different from the dissertation she had initially planned, for reasons that will become obvious, and a guide, a Dene man who had grown up in the region and who had lived in it his entire adult life, and who knew the terrain the way you only know a place when it has been your home, and your classroom, and the context of your family's history for as long as you can remember. It was the guide who knew the cave existed. He had known about it since childhood. His grandfather had told him. His grandfather's grandfather had told his grandfather, and the information had passed backward, in time as far as anyone in his family could trace, which was as far as the oral tradition went, which was farther than any of the survey team fully understood when they departed the frozen lake with their sleds and their equipment and their plans for a routine geological survey. He agreed to take them. He said later, in the single interview he gave to a regional newspaper that remains one of the most important public accounts of the discovery, that he had thought they would look around, take their measurements, and leave. He had escorted outside researchers to significant places before, and this was always roughly what happened. A period of activity, a period of writing things down, a departure, and then a silence that could last for years before any results emerged, if they emerged at all. He had not expected this to be different. He had not expected that he would spend years afterward trying to find the right language to explain to his community and to himself what had happened in the place his grandfather had always treated with particular care. The approach to WR7 from the lake took 2 days. The terrain between the landing site and the cave entrance is not impassable, but it is demanding. A combination of open valley floor, forested slopes, and the kind of rocky upland terrain that requires constant attention to footing. In January, with snow depths of a meter or more in sheltered areas, and the temperature sitting around minus 30 Celsius, the approach becomes an exercise in the sustained management of physical stress. You move carefully, you watch where you put your feet, you pay attention to the people behind you and in front of you. You do not allow your mind to wander far from the practical demands of forward movement, because in this kind of cold, with this kind of terrain, inattention is the beginning of a sequence that ends badly. Dr. Vasiliev's field notes, partially declassified and accessible under access to information requests, though with significant portions still redacted, describe the approach in the methodical, observational language of scientific fieldwork. The character of the snow, the vegetation zones, the geological formations visible at the surface, the condition of the ice on the creek crossings. But there are passages in these notes that depart from the standard register that feel like something more personal, forcing its way through the professional framework. She wrote at the end of the first day that the landscape had a quality she found difficult to articulate but felt compelled to record, not simply remote, something more specific. The feeling, she wrote, of being in a place that had not been processed by human attention in the way that even wilderness areas usually have been, in the way that a place with a name or a designated boundary or a management plan has been processed, even if nobody is currently standing in it. This place felt unprocessed, felt like the land before the idea of land had been formalized into categories. On the second day, she noted that the guide's manner had shifted slightly as they moved into the final kilometers of the approach. Not behavioral changes she could point to specifically. He was still methodical, still attentive, still doing his job with the focused competence that had been consistent throughout. But something in how he moved had changed. She used the word ceremonial, then crossed it out and wrote deliberate, then wrote that she was not sure the distinction was meaningful. He was moving like someone approaching something significant. She found herself moving more quietly without being asked to, and she noted that she did not entirely understand the impulse. They reached the cave entrance in the late afternoon of the second day, in the gray, low light of a northern January, when the sun is not so much setting as completing the arc of its minimal daily appearance. The entrance was not what anyone had imagined, smaller than expected, a crack in a limestone outcropping, perhaps 1.5 meters wide and barely 1 meter tall, set into a hillside and partially obscured by ice formations that had built up over what was visibly many seasons. Without knowing it was there, you could walk within 10 meters of it and see nothing. Without the guide, the survey team would have walked past it. He stood at the entrance for several seconds before saying anything. Then he said what his grandfather had told him, that this was a place that had been known to the people for as long as anyone could say, and that you did not take more than you came in with. The team suited up. They ran their atmospheric monitoring equipment, standard procedure in any cave environment, because radon gas and elevated carbon dioxide can accumulate to dangerous concentrations in enclosed spaces, and the consequences of ignoring this are severe. The monitors read normal. They checked their lighting. They checked their communication equipment. Dr. Vasiliev ran through the safety checklist that years of cave work had made automatic, and then she and the team filed through the entrance. The initial passage from the entrance is approximately 30 meters of tight, low crawlway that requires the kind of full-body negotiation that reminds you that caves are not built for human comfort. You move on your hands and knees, sometimes lower, pushing your pack ahead of you, aware of the rock pressing against your back and the cold floor against your palms, and the way that the confined space amplifies every sound you make, your breathing, the scrape of your equipment, the small involuntary noises that emerge when you are uncomfortable and concentrating hard. There is nothing pleasant about it. There is also something strangely focusing about it. You are entirely in your body, entirely in the immediate present, unable to think about anything except the next meter of passage. Then it opens. This transition from the tight passage to the main chamber is the moment that every person who has been inside WR7 seems to mention when they talk about the experience. It is the moment that the cave changes from a difficult access problem to something else entirely. The passage widens first, then the ceiling rises, then you realize you're standing up, and then your headlamp is not reaching the far wall, and then you understand that you are in a large space, genuinely large enough that the boundaries are not immediately apparent, and the darkness has depth rather than surface. The main chamber of WR7, as measured in subsequent surveys, is approximately 400 square meters in floor area, with a ceiling that reaches 11 meters at its highest point. The walls are limestone, pale and striated with the marks of their formation, smoothed in some areas by water flow and rough and crystalline in others. There are stalactite formations along one section of the northern ceiling, formed by mineral-laden water dripping over geological time into the shapes that make them look, in certain lighting angles, like the keys of an instrument that nothing alive plays anymore. The air temperature inside the main chamber is -8 Celsius, significantly warmer than the outside, because the rock mass of the hillside acts as insulation and the cave's interior has its own thermal equilibrium that the outside climate does not fully penetrate. The air is very still. This is noticeable immediately after 2 days of moving through wind. Caves are still in a way that open environments never are, a stillness that feels absolute, that seems to belong to the space rather than simply to describe the current weather conditions. The stillness is part of what makes the silence feel so complete, and the silence is part of what makes the scale of the chamber feel larger than its measurements suggest. Sound does not carry in the usual way. Voices stay close to the speaker. The darkness past the range of your headlamp is total and absolute and seems to press back. And then your headlamp finds the bones. They were not scattered randomly across the floor in the way that bones accumulate in a natural death deposit where animals die or are carried by scavengers and the material disperses over time across the available surface. These bones were concentrated. They occupied the center of the chamber and extended along the eastern wall in a distribution that, to Dr. Vasiliev's experienced eye, registered immediately as unusual. Not archaeological immediately. She did not leap to that conclusion because a disciplined researcher does not leap, but unusual. The kind of distribution that makes you slow down and look more carefully before you do anything else. She called the team to a stop. She swept her headlamp slowly across the floor of the chamber, following the distribution of material, trying to build a general picture before approaching and potentially disturbing anything. The junior researcher was already moving forward, and she stopped him with a word. The field technicians read the situation and held their positions. The guide stood near the entrance passage, watching. There were large bones, very large, bones that even in the indirect light of headlamps could be identified as coming from substantial animals, not the medium-sized fauna of the contemporary boreal forest, not moose or caribou, but something bigger. Leg bones with dimensions that she mentally catalogued, silently as she looked. Rib sections, partial skulls. The accumulation was significant in quantity, not just in size. There was material from multiple individuals, from multiple species, in a quantity that exceeded what a natural death deposit would typically produce. There were dark patches on the floor, 2 of them visible from where she stood, round or oval in outline, surrounded by what looked in the headlamp light like debris. Small pale fragments mixed with the darker material. Fire features. She knew them immediately because she had seen them before in other cave sites, though never from a period that the stratigraphic context here was already beginning to suggest. You learn to recognize ancient hearths quickly once you have seen them. The oxidized soil, the charcoal, the arrangement of associated stones, the halo of ash that extends beyond the central burn area. These had all of those elements. And there were stones, not geological stones, not the limestone fragments that had fallen from the walls and ceiling over time. These were different, smaller, sharper edged, in a range of materials that included chert and quartzite, materials that do not occur naturally in the cave substrate. Someone had brought these stones here, and some of them had clearly been worked, edges deliberately shaped into cutting or scraping surfaces by the removal of small flakes, a process that leaves distinctive signatures that even a geologist can recognize. Dr. Vasiliev turned to the guide. She asked him if he had ever been inside the cave before. He said no. He said his grandfather had told him not to enter it casually. He said what the cave looked like inside he had not known. She turned back to the chamber and spent a long moment doing nothing but looking. Then she began to record. Archaeological documentation is slow. It is deliberately, necessarily slow, because the process of excavation and recording is irreversible. You cannot put the sediment back, you cannot unmove a bone or uncollect a sample, and every action that advances the investigation destroys the original context permanently. This means that good archaeological fieldwork moves at a pace that can be deeply frustrating to people who want to know what they are looking at, because knowing what you are looking at requires first documenting the exact position and condition of everything. Before you understand it, before you know whether it matters, before you know if the detail you just recorded will turn out to be crucial or incidental. Dr. Vasiliev spent the first day in WR7 documenting the surface material before touching anything. She photographed the chamber from multiple positions and angles. She sketched the distribution of visible material on a grid drawn in her field notebook. She noted the position, orientation, and preliminary identification of every bone cluster and artifact concentration she could see from the floor surface. She noted the fire features, their dimensions, their visible contents. She walked the perimeter of the chamber and noted the wall and ceiling characteristics. She checked the atmospheric monitors repeatedly. She collected absolutely nothing on the first day. What she was seeing, as the documentation process forced her to look at it systematically rather than broadly, was resolving into something that her scientific training and field experience were processing simultaneously on multiple levels. The surface material was consistent with human occupation, not just casual passage through the cave, people sleeping here once or twice in an emergency, leaving minimal traces. Sustained, repeated occupation. The quantity of faunal remains suggested feasting or food processing over multiple visits. The fire features showed evidence of multiple use episodes in their layered ash deposits. The stone tools were consistent with a functional assemblage, the kinds of tools people bring to a place where they are working, not decorative objects or ritual deposits. On the second day, she moved closer. She began examining the bone material in detail, examining surfaces under magnification, using the hand lens she carried, and she found the cut marks. Cut marks on archaeological bone are among the most unambiguous signatures of human activity that the discipline possesses. They are straight, they are sharply incised, they occur in patterns consistent with the movements of stone tools during butchery or hide processing, and they do not occur naturally through geological or scavenging processes in ways that could be confused with deliberate human cutting. She knew them immediately when she saw them. She knew them, and she knew where they were, on leg bones from an animal whose dimensions she was now measuring and comparing against the reference data she carried in her memory, and the answer she kept arriving at was an animal she had never expected to encounter evidence of in this context, in this cave, in this moment. The cut marks were on mammoth bone. The woolly mammoth, Mammothus primigenius, went extinct at the end of the Pleistocene epoch, approximately 10,000 years ago in most of its range. The last population survived on Wrangel Island in the Arctic Ocean until about 4,000 years ago, persisting in isolation after the mainland populations had vanished. They were large animals, up to 3.5 meters tall at the shoulder, weighing 6 to 8 tons in the largest individuals, covered in the thick, layered coat of hair and undercoat that gave them their common name and that suited them to the cold conditions of the Pleistocene steppe and tundra. They were herbivores, grazing on the abundant grasses and sedges of the mammoth steppe ecosystem that covered vast areas of northern Eurasia and North America during the last glacial period. Their bones are found across the north in various contexts. This is not in itself unusual. Mammoths died, and their bones were incorporated into sediments that are now accessible in eroding riverbanks and in the frozen sections of permafrost that thaw along northern coastlines. Finding mammoth bones in a Canadian cave would be interesting, but not extraordinary. Mammoths lived in the region. Finding mammoth bones with cut marks in a Canadian cave is something entirely different. Cut marks mean people. They mean stone tools. They mean human hands processing that mammoth, whether the animal was hunted or scavenged, whether the people killed it or found it dead and made use of the resource. The marks on the bone mean deliberate human action on the body of an animal. And a mammoth in a cave in northern Canada with cut marks means that people were in this cave when mammoths were still alive. Mammoths were still alive 10,000 years ago. The standard model of North American prehistory placed the first human arrival at approximately 13 to 15,000 years ago. Before the mammoth's extinction, yes, but placing the earliest human-mammoth interaction at the end of the mammoth's time in the Americas, not at a point significantly earlier. This was consistent with the Clovis framework. People arrived relatively late, spread quickly, and the megafauna extinction that followed their arrival was partly or substantially the result of that new, efficient predator appearing suddenly on a continent whose large animals had no evolutionary preparation for human hunting pressure. But the cave's stratigraphy was already telling Dr. Vasiliev something that went beyond simply finding cut-marked mammoth bone. The stratigraphy, the layering of the deposits, was telling her that the human occupation of this cave extended deep, much deeper than she had expected. And when she opened her first test trench on the third day, careful and methodical and fully aware that she was working outside the formal excavation mandate of a geological survey, but compelled by the evidence to proceed, the stratigraphy became something she could not ignore and could not easily explain. Below the surface deposit, the layer corresponding to the bones and artifacts visible on the floor, there were more layers. This is not unusual in any site with a long history of use. Material accumulates, and earlier deposits end up buried under later ones. What was unusual was the character and depth of the sequence. There were occupation layers, dark, rich deposits full of charcoal and bone fragments and occasional stone artifacts, separated by sterile lenses of fine silt that represented periods when the cave was not in use, when natural processes of sediment deposition were not being interrupted by human activity. 3 occupation horizons were clearly visible in the test trench profile within the first 40 centimeters of depth, before the trench hit material that the cold had consolidated into something harder than the upper deposits. Each occupation horizon was associated with charcoal. Good charcoal, abundant, clearly defined, representing wood fuel that had been burned completely and then left in place rather than being cleaned up or scattered. Ideal material for radiocarbon dating. Dr. Vasiliev collected samples from each horizon methodically, bagging and labeling them with the precision that years of fieldwork make automatic, noting the exact stratigraphic position of each sample, the associated material, the visible characteristics of the deposit. She knew what she was doing. She knew why she was doing it with such care. She was collecting evidence that she believed might be extraordinary, and extraordinary claims require extraordinary documentation. On the morning of the 4th day, she transmitted a summary to her contact at the Geological Survey of Canada. She described what she had found in language that was careful and qualified, and still by any measure alarming to anyone who understood what it implied. The contact asked several questions. She answered them. The call ended. 2 hours later, he called back and told her to cease excavation, secure the samples, and await further instructions. She knew what the further instructions would be before they arrived. The Clovis model of North American prehistory has a history worth understanding, because the discovery at WR7 makes no sense without understanding what it was confronting. The model was not arbitrary. It was built on real evidence, developed over decades of careful work, and it answered questions that needed answering. Its problem was not that it was constructed badly, but that it was held too firmly for too long after the evidence began to push against its edges. The story begins in 1932, near Clovis, New Mexico, where workers digging a water tank exposed a layer of ancient bones in association with distinctive fluted spear points, stone projectile tips with a characteristic groove running up the base, a design that allowed them to be hafted onto spear shafts with an efficiency that made them remarkably effective hunting tools. The bones were from Pleistocene megafauna, mammoths, ancient bison, horses. The association of the points with the bones, confirmed through careful excavation, established that the people who made the Clovis points had lived at the same time as these animals and had hunted them. Radiocarbon dating in subsequent decades established the age of Clovis sites at approximately 13,000 to 13,500 years before present. Over the following decades, similar assemblages were found across North America, from Montana to Virginia, from Mexico to as far north as the evidence could be recovered. The consistency of the Clovis technology across this vast geographic range, combined with its apparent temporal consistency, led to the model that became the standard. Clovis people were the first Americans, arriving via the Bering Land Bridge and the ice-free corridor approximately 13 to 15,000 years ago, and spreading rapidly south and east across a continent that had never seen human hunters before. The speed of the spread, implied by the near simultaneous appearance of Clovis sites across the continent, was explained by the abundance of naive megafauna on a virgin continent, unlimited food, no natural predators, rapid population growth, and geographic expansion. The model was elegant. It was supported by significant evidence, and it became, in the way that successful scientific models sometimes do, something closer to assumption than hypothesis. Challenges to the Clovis first model were met with skepticism that was not always purely scientific in character. Sites claiming pre-Clovis dates were scrutinized with a rigor that was not consistently applied to Clovis sites themselves. Researchers who advocated for pre-Clovis occupation developed the particular combination of persistence and defensiveness that comes from spending years advancing arguments against institutional resistance. The resistance began to crack in the 1990s. Monteverde, a waterlogged site in southern Chile, where Tom Dillahay and his team had been documenting human occupation since the 1970s, was subjected to a formal site visit by a team of skeptics in 1997. After seeing the evidence directly, the visiting researchers accepted the site's date of approximately 14,500 years before present, more than 1,000 years before the supposed opening of the ice-free corridor that Clovis people were thought to have used. Monteverde's acceptance did not collapse the Clovis model immediately, but it established definitively that people had been in the Americas before Clovis, and it opened the door to a serious reconsideration of the evidence that had been accumulating at the margins of the consensus. By 2003, the consensus was in genuine flux. The ice-free corridor hypothesis was being subjected to detailed scrutiny, and the emerging evidence suggested that the corridor had not been ecologically viable, capable of supporting a migrating human population, until around 13,000 years ago, meaning that the first Americans could not have arrived via that route as early as some genetic and archaeological evidence was beginning to suggest. The coastal migration hypothesis, which proposed that people had traveled south along the Pacific coast in watercraft, avoiding the interior ice entirely, was gaining traction. A few sites in North America with dates older than Clovis were being taken seriously for the first time. Into this context, WR7 arrived like a key inserted into a lock. The radiocarbon results from the WR7 samples did not arrive all at once. They came in stages from different laboratories over a period of weeks, and Dr. Vasiliev received them in the careful, methodical way that scientific results are typically communicated, not with drama, not with ceremony, but as numbers in a report, with uncertainty ranges and technical caveats and the language of probability rather than certainty. The upper occupation horizon, the surface level deposit, the most recent activity in the cave, dated to between 5,000 and 7,000 years before present. This was consistent with what was known about human activity in the region during the Middle Holocene. It was not surprising. It was a baseline, a confirmation that the most recent layer was what the stratigraphy suggested it was. The second occupation horizon, the layer below the first, separated by a sterile lens of silt, representing a gap in use, dated to approximately 22,000 years before present. This date fell within the last glacial maximum, the period between approximately 26,000 and 19,000 years ago, when the ice sheets covering North America reached their greatest extent. At 22,000 years before present, the Laurentide and Cordilleran ice sheets were at or near their maximum, and the accepted understanding of North American prehistory held that the continent's interior was essentially uninhabited. There was no way for people to have been there, because the ice had blocked all routes of access, and the ice-free corridor would not open for another 9,000 years. But there they were, in a cave in the Mackenzie Mountains corridor, 22,000 years ago. Someone had been living. The third horizon, the deepest one that the test trench had reached, the one with the cut-marked mammoth bones and the simple core and flake stone tools, and the fire feature constructed from flat stones brought from elsewhere. The date that came back from the laboratory for the charcoal samples from this horizon was 28,000 years before present. 28,000 years. The number requires sustained attention to feel. Let us try to feel it. 28,000 years is not twice as old as the oldest Egyptian pyramid. It is roughly 10 times older. It predates the construction of Stonehenge by 23,000 years. It predates the earliest cave paintings at Chauvetit in France by about the same period of time. It places human occupation in northern Canada at a moment when Neanderthals were still present in Europe, when the woolly rhinoceros was still alive in Eurasia, when the landscape of what is now the Northwest Territories was beginning the transition into the full glacial conditions that would define the last glacial maximum, conditions that created a deep cold, unlike anything the contemporary North experiences, a cold that nonetheless sustained life, that sustained people who were warm in that cave on nights that were colder than anything most of us will ever encounter. The consistency of the dates across multiple samples from the same layer was important. One anomalous date can be a result of contamination, of intrusion of older material into younger deposits, of the many technical problems that plagued early radiocarbon dating and that modern methods have largely addressed but not entirely eliminated. Multiple consistent dates from multiple samples in clearly defined stratigraphic context, confirmed across different laboratories using different methods, is a different kind of evidence. It is the kind of evidence that is very difficult to dismiss on methodological grounds without dismissing the entire framework of modern radiometric dating. The dates were consistent. Multiple samples from the deepest occupation horizon, processed by 2 different laboratories, produced results clustering around 28,000 years before present. The uncertainty ranges overlapped. The dates agreed. Dr. Vasiliev spent the first several months after the site closure in a condition she later described as professionally suspended, not forbidden from working, not explicitly censored, but held in a state of official uncertainty where she had extraordinary evidence and was not yet in a position to do anything with it publicly, the encrypted call to Ottawa had initiated a process that moved at the pace of bureaucratic institutions rather than scientific urgency, a pace that is genuinely maddening to someone who has just spent 4 days in a cave that has rewritten their understanding of human history. The process involved multiple levels of review: scientific review, legal review, policy review, and critically, consultation with the Indigenous governments of the Northwest Territories. This last element was not a formality. The territorial Indigenous governments had real authority in this process, authority established through land claims agreements and treaty negotiations that had been ongoing since the 1970s, and that had produced a legal framework giving Indigenous nations substantial influence over decisions about archaeological sites in their traditional territories. The cave sat within a region whose territorial connection to the Dean people was both ancient and, as the WR7 evidence would eventually confirm, demonstrably continuous from a period far earlier than any previous documentation had established. The relevant Indigenous governments had governance rights and responsibilities with respect to cultural heritage in their territory, and they had both the legal authority and the moral standing to insist that any research and any publication of research from the site proceed through a process that respected and included them. This was not suppression of the evidence. It was, in fact, the application of a legal and ethical framework that had been developed specifically to prevent the kind of academic colonialism that had characterized the relationship between scientific institutions and Indigenous peoples for most of the 20th century, a relationship in which researchers arrived, took samples and data, published papers that drew conclusions about Indigenous cultures and identities, and gave the communities themselves no role in defining or communicating the findings. The consultation process that slowed the publication of the WR7 findings was the corrective to that history, an attempt to do the work differently. It was still frustrating. Dr. Vasiliev has said this clearly in the few contexts where she has addressed it. She had evidence of extraordinary significance, and she wanted to share it with the scientific community on a scientific timeline. The bureaucratic and legal process moved on a different timeline. The gap between those two timelines was genuinely painful for her, and she does not pretend otherwise. But she also says that the consultation process changed the research in ways that improved it. The Indigenous researchers and community members who were brought into the project as partners brought knowledge and perspective that the original survey team did not have. They brought oral traditions and landscape knowledge that provided context for the archaeological findings. They brought questions that the conventional archaeological framework had not thought to ask, and they brought a relationship to the site, a historical, familial, deeply personal relationship to a place that their ancestors had occupied, that gave the entire project a dimension of human meaning that purely academic research rarely achieves. The Diné people of the Northwest Territories are not a single nation, but a grouping of related nations whose languages and cultures share deep common roots and whose territories together cover a vast section of the subarctic interior of Canada. The name Dean means simply the people in the Athapascan languages of the group, the same meaning as the self-names of many Indigenous peoples worldwide, and it is used both as a collective identifier for the broader grouping and as the name of specific nations within it. The Den include the Yellowknives, Den, the Twocho, the Dehcho, First Nations, the Sahtu, Den and Métis, and others, each with distinct territories, distinct governance structures, and distinct cultural traditions, connected by language families, and by a shared history of adaptation to and relationship with the boreal and subarctic environments of the North. The oral traditions of the Dene nations contain knowledge that has been transmitted across many generations, encoded in stories and ceremonies and practical teachings that carry information about the environment, the animals, the land, and the history of the people's presence in it. This knowledge has not always been taken seriously by outside researchers. The history of ethnographic work with Indigenous peoples in Canada includes a long and embarrassing period during which oral traditions were documented primarily as curiosities or as evidence of cultural difference, rather than as serious archives of actual historical information. The idea that a story told around a fire in a Dene community might accurately reflect events that occurred thousands of years ago was not one that most 20th century researchers were prepared to entertain. The evidence from WR7 contributed, in its specific and local way, to a broader intellectual shift that has been underway in the disciplines that study human prehistory. The growing recognition that oral traditions can and do preserve accurate information about events across very long timescales is not a fringe position anymore. It is supported by multiple converging lines of evidence from different parts of the world. The specific tradition maintained by the guide's family and community, that the cave was old, that it was significant, that it deserved particular respect and careful approach, is consistent with what the archaeological and genetic evidence demonstrates about it. The tradition did not preserve specific dates or specific details, but it preserved the essential fact. This place is significant. This place is old. Treat it accordingly. The fact that this tradition had been carried across an unknown number of generations through periods of enormous disruption, the residential school era, the fur trade era, the disruptions of colonization that affected every aspect of Dene life and culture, and had survived intact enough to be communicated to the guide by his grandfather and by his grandfather before him, is itself a remarkable form of evidence. Something about the cave's significance was important enough to the community to be preserved even when so much else was under pressure. When the research team presented the scientific findings to the relevant Indigenous governments and communities, the response was not surprise. Multiple people who were present for those discussions have described the same essential quality of reception, a quiet, settled acknowledgement, an absence of the shock that the outside researchers perhaps expected. The findings confirmed what the tradition had already held. The people knew the cave was old. The scientists had found out how old. The ancient DNA analysis of the human remains recovered from WR7 in subsequent excavations, conducted after the consultation framework was established and under the oversight of a joint research committee that included Indigenous members, produced results that were among the most technically impressive ancient genomics work done on North American material. The cold, stable environment of the cave had been extraordinarily kind to the genetic material in the bone samples. Ancient DNA is fragile in ways that even experts find difficult to fully communicate. The double helix of DNA begins to degrade as soon as the organism that produced it dies. Oxidation, hydrolysis, microbial activity, the basic chemistry of the environment, attacks and fragments the molecule continuously, breaking the long chains of genetic information into shorter and shorter pieces until, in most environments, nothing useful remains within a few thousand years. Under ideal conditions, cold, dry, alkaline, fragments can persist much longer. But most ancient samples, even from cold environments, yield DNA that is highly fragmented, heavily damaged, and present in quantities that make the extraction of meaningful information a genuine technical challenge. The WR7 samples were exceptions. The permafrost conditions had suppressed chemical degradation to a degree that astonished the laboratory teams who processed them. The bones yielded DNA that was fragmentary by modern standards, but exceptional by ancient standards. Long enough fragments, present in sufficient quantity, to allow reconstruction of meaningful portions of the individual's genomes using the next-generation sequencing methods that had become standard in the field by the time the samples were processed. What the genetic analysis revealed was a story of relationships and separations played out across time. The individuals from WR7 belonged to a population that was related to, but clearly distinct from, the ancestral populations of later indigenous peoples in North America. They shared genetic variants with populations from northeastern Siberia, the region that is understood to be the source population for the peopling of the Americas. But the nature of the sharing suggested a deep divergence. The WR7 population had separated from the Siberian source population significantly earlier than the Clovis ancestors, their genetic lineage diverging at a time consistent with their presence in North America at the dates indicated by the radiocarbon evidence. This was important for what it implied about the process of the Americas peopling. The standard model had imagined essentially a single crossing, a founding population making the passage across Beringia and into North America, then spreading south and diversifying into the variety of indigenous peoples who occupied the continent when Europeans arrived. The genetic evidence from WR7 suggested something more complex, multiple crossings, or a single very early crossing that left a founding population in North America, which then diversified while subsequent migrants from the same general source population were making their own way into the continent. The WR7 people were not simply early Clovis people. They were a distinct lineage with a history in North America that predated Clovis by many thousands of years, and that had been developing and adapting in that time. The comparison between the WR7 genomes and the genomes of contemporary indigenous peoples in the region produced a finding that the research team had hoped for, but had not been certain they would see. The WR7 individuals were ancestral to, or closely related to, ancestral populations of several contemporary DNA groups. The genetic connection was real. The guide whose grandfather had told him the cave was significant was, in a biological sense, related to the people who had made it significant 28,000 years ago, not metaphorically, genetically. His family had been in the region for a span of time that exceeds the entire recorded history of civilization by a factor of more than 10. The publication of the WR7 findings in the international scientific literature in 2008 was not the media event that a discovery of this magnitude might, in a different field or a different culture, have produced. Archaeological findings, even genuinely revolutionary ones, tend to move through public consciousness slowly. The paper appeared in a major journal, was covered in science journalism with varying degrees of accuracy, produced a round of commentary in the professional literature, and gradually found its way into the revised frameworks that archaeologists and geneticists working on North American prehistory were constructing to replace the discredited Clovis first model. The scientific debate about the findings was substantive, and in some cases heated. The skeptical arguments focused primarily on methodology, the possibility of contamination in the radiocarbon samples, the possibility of intrusion, natural processes by which older material can be incorporated into younger deposits, producing apparent dates that do not reflect the actual age of the associated human activity. These are legitimate concerns in any radiocarbon dating context, and the WR7 team addressed them with care in the paper and in the subsequent correspondence and commentary. The contamination argument failed because the samples had been collected with full awareness of contamination risks and using protocols designed to minimize them. The pre-treatment methods used for the bone samples were specifically designed to remove modern carbon that might distort dates toward the present. The charcoal samples were large, well-defined, and collected from clearly identified stratigraphic contexts. So multiple independent samples from the same layers produced consistent results. The internal consistency of the dates, the fact that the three occupation horizons produced dates that made stratigraphic sense, with the deepest layer being the oldest and the layers proceeding in the expected temporal order, was difficult to explain through contamination because contamination does not typically produce internally consistent stratigraphic sequences. The intrusion argument required the proposal that very old material, 28,000-year-old charcoal and bone, had somehow moved downward through the deposit from older underlying contexts that were not identified in the excavation. This kind of downward movement of material does occur in cave sites under certain conditions, but it leaves detectable signatures in the sediment, and the WR7 excavations found no evidence of the sediment disturbance that would indicate intrusion. The sterile lenses between occupation horizons were intact, undisturbed, with no evidence of bioturbation or hydrological activity that could move material between layers. By the early 2010s, the WR7 dates were accepted by most archaeologists working on North American prehistory. The discussion had moved from whether the site was real to what it meant for the broader understanding of the Americas peopling and for Canadian history specifically. The cave itself has not been idle since the initial discovery. Research seasons have continued, conducted under the joint framework established through the consultation process, with excavations advancing carefully and methodically through the deposit. The picture that has emerged over more than 2 decades of work is considerably more complex and more richly textured than the initial survey could have suggested. The cave was not continuously occupied across the span of time that the radiocarbon dates bracket. The sterile lenses between occupation horizons represent periods of abandonment, times when the people who used the cave were elsewhere, or when the cave was inaccessible due to ice or other environmental conditions, or when the human population that knew and used it had been affected by events that the archaeological record cannot directly document. The occupation events were episodic, repeated use over periods of weeks or months, then gaps. But the pattern of return, the fact that the cave was used, abandoned, and used again across a span of more than 20,000 years, speaks to a consistent cultural knowledge of the site. Generation after generation, someone knew about this cave and came back to it. The animal remains recovered across the full excavation sequence reflect the environmental changes of the late Pleistocene and early Holocene in extraordinary detail. The oldest layers contain the megafauna, mammoth, steppe bison, horse, and other species that went extinct at or near the end of the last ice age. The middle layers show the transition, declining frequency of megafauna alongside the appearance of species more consistent with the modern fauna of the region, caribou, moose, smaller mammals. The upper layers reflect essentially the modern ecological community. The cave is a stratigraphic archive not just of human presence, but of the profound ecological transformation that accompanied the transition from the Pleistocene to the Holocene, the end of the world that the first occupants of WR7 knew, and the gradual emergence of the world their distant descendants inherited. This ecological story is in some ways as significant as the human story. The transition from the mammoth steppe to the modern boreal and tundra ecosystems was one of the most dramatic ecological transformations in the history of North America, and it was happening at the same time as the people who occupied WR7 were adapting their technology, their subsistence strategies, and their cultural frameworks to a world that was changing in ways that no individual or generation could fully witness. The animals they hunted disappeared. The plants they used shifted northward, and changed in character. The climate warmed, and the ice retreated, and the landscape became something different from what it had been when the oldest layers of WR7 were being laid down. And the people stayed, they adapted, they carried forward the knowledge of the cave, the knowledge of the land, the knowledge of how to survive in an environment that was generous to those who understood it and lethal to those who did not. There is a practical dimension to the story of WR7 that is rarely discussed in the academic literature, but that bears consideration: the experience of actually working in the site. Research field work in a cave like WR7 in the conditions of the Canadian North is demanding in ways that most people do not associate with academic work. The physical environment is uncompromising. The cold is constant, and it is the kind of cold that seeps in through insulation and makes fine motor tasks. The careful manipulation of instruments, the gentle brushing of sediment from fragile bone surfaces, the precise placement of samples in labeled bags, progressively more difficult. The lighting is entirely artificial, which has psychological effects that are subtle but real. Without the visual cues of natural light, the sense of time passing becomes unreliable, and the cave's interior seems to exist outside the normal rhythm of day and night. The work itself requires a level of sustained concentration that is taxing across a full day, and a full day in the cave typically ends with team members returning to camp exhausted in a way that is partly physical and partly something less easy to name. The researchers who have spent significant time in WR7 tend to describe the psychological experience of being in the cave in ways that are consistent across individuals who would not necessarily agree on how to interpret what they felt. The word that comes up repeatedly in various forms is weight. The cave feels heavy with accumulated time. This is, of course, not a physical sensation. Time has no mass, and the feeling of its weight is a product of human psychology reacting to context. But the context is extraordinarily rich. Every square meter of the cave's floor contains evidence of thousands of years of human activity. The walls and ceiling are unchanged from what the first occupants saw. The cold and the darkness are unchanged. The stillness is unchanged. You are physically present in a space that has contained human consciousness for 28,000 years, and whatever you think about supernatural phenomena or the persistence of the past, that fact produces a register of experience that the word historical does not quite capture. One graduate student who spent 2 field seasons at WR7 wrote a reflective piece for a humanities journal, a departure from her usual scientific writing that her committee initially questioned and that she later described as the most important thing she had published. She wrote about the experience of sitting in the cave during a break in the work and allowing herself to think about the people who had occupied it before her. Not in the abstract way that archaeologists are trained to think about ancient populations, as demographic groups, as bearers of cultural traditions, as examples of adaptive strategies in changing environments. She allowed herself to think about them as people who had had bad days and good days, people who had loved other people who had been children once, who had been taught the skills they needed by people who had been taught those same skills by people who were themselves children once, people who had sat in this same cave, probably in the same spot, probably looking at the same darkness beyond the radius of their fire, and thought whatever people think when they are warm and fed and the work of the day is done. She wrote that this kind of thinking is considered inappropriate in scientific contexts, and that she had gradually come to believe that this inappropriateness was itself worth questioning. The insistence on abstracting ancient peoples, on treating them as examples rather than as individuals, as evidence rather than as people, was a methodological choice that had consequences for how their history was understood and communicated. The cave pushed back against abstraction. It was too specific, too concrete, too physically present in its evidence. You could not sit in it and think in abstractions. The evidence of human life was too immediate. The closure of WR7 to public access remains in effect. The official closure documentation, available through access to information requests, lists the preservation of fragile geological formations, the ongoing nature of scientific research, and the cultural heritage protection requests of the relevant Indigenous governments as the grounds for continued restriction. All three of these reasons are genuine. None of them is the kind of suppression that the word closure implies when it appears in headlines. The fragile geology argument is real. The stalactite formations in the northern section of the main chamber would not survive unrestricted public access. Speleothems, the collective term for cave formations including stalactites, stalagmites, and the various other mineral precipitates that form in cave environments, grow at rates of millimeters per year under the best conditions and require moisture and air chemistry that can be disrupted by human traffic, breath, and body heat. Formations that took thousands of years to develop can be destroyed in a single visit by careless tourists. The preservation argument for restricting access to cave formations is not invented to serve other purposes. It is a standard, well-documented concern in cave management worldwide. The research argument is also real. The excavations in WR7 are ongoing, and active excavation sites require controlled access to maintain the integrity of the stratigraphic record. Visitors who walk through the cave during an active field season would inevitably disturb things. Loose sediment would be kicked into excavated units. The spatial relationships that give the material its meaning would be disrupted. The careful microstratigraphy that the team works to document would be altered by footfall. The cave cannot be both an active research site and a tourist destination. The cultural heritage protection argument is perhaps the most significant, and certainly the one that has been given the most prominent role by the Indigenous governments who have asked for the restriction to be maintained. The cave contains the remains of ancestral individuals. It contains material that is culturally affiliated with living Indigenous communities. The request that it be treated with the same respect that would be accorded to any other cemetery, the same respect that, it is worth noting, colonial institutions have historically been willing to extend to European burial sites, but have consistently failed to extend to Indigenous ones, is a reasonable request, and it has been honored. There are people who argue that the cave should be opened, that significant historical sites should be accessible to the public, that the closure is a form of institutional selfishness in which researchers hoard access to shared heritage. This argument contains a real concern. Public archaeological sites are valuable for public education, and the instinct to open significant discoveries to the people whose cultural heritage they represent is not wrong in principle. But the concern is undermined by the specific character of WR7. It is a fragile, active, culturally sensitive site whose ongoing research is producing knowledge that is being shared through public communication, even if the site itself is not accessible. The choice is not between public access and secrecy. It is between careful, controlled research, with Indigenous partnership, and rapid degradation of an irreplaceable archive. The cave will remain closed for the foreseeable future. This is, on balance, the right decision. The significance of WR7 for the history of Canada is not exhausted by the specific findings about dates and genetics and the peopling of the Americas. Those findings are genuinely extraordinary and genuinely important, and they will continue to reshape the professional understanding of North American prehistory as the excavations continue and the analysis deepens. But the cave's significance extends beyond the technical. Canada tells a particular story about itself. It is a young country founded in 1867, shaped by the meeting of British and French colonial traditions and by the subsequent waves of immigration that transformed the demographic character of the country over the following century and a half. This story is not false. The political entity called Canada is relatively recent, and the processes that created it were genuinely formative in ways that still define the country's institutions, culture, and character. But this story has a shadow side, a vast and largely unacknowledged underside, which is the history of the land and the people before Confederation. The Indigenous peoples of what is now Canada were not a backdrop to the creation of the country. They were not a natural feature of the landscape, like the forests and rivers, that the colonial enterprise encountered and worked around. They were nations, politically organized, culturally sophisticated, ecologically expert peoples who had been living on the land for timescales that dwarf European civilization, who were subjugated, displaced, and systematically stripped of their rights, their lands, their cultures, and in many cases their children by the colonial project. The evidence from WR7 does not change what happened to Indigenous peoples in Canada. It does not undo the residential school system or the 60s scoop or the hundreds of broken treaties or the ongoing crises of Indigenous communities that are the direct legacy of colonial policy. But it does change the context in which those histories must be understood. It establishes, with the full weight of scientific evidence, that the relationship between Indigenous peoples and the land of Canada is not recent, not incidental, and not the product of a migration that, in the colonial imagination, was not that different from the migrations of European settlers. The relationship is ancient in the deepest sense of that word, ancient enough that the people who first occupied WR7 were living in what is now Canada before the most recent ice age had reached its maximum, ancient enough that their descendants survived the end of the ice age, the extinction of the megafauna, the transformation of the landscape, the arrival of new peoples, and the full span of everything that we call recorded history, and they were still there when the first Europeans arrived. This is the history that the cave documents, not as mythology, not as oral tradition that might or might not be historically accurate, as physical evidence, dated and verified and replicated and subjected to the full apparatus of modern scientific scrutiny and found to be real. There is a passage in the memoir piece that Dr. Vasiliev published in 2012 that has been quoted in several subsequent discussions of the WR7 site, and that deserves to be encountered in full because it captures something about the experience of the discovery that the scientific papers necessarily cannot. She describes sitting alone in the main chamber of the cave on the last night before the team's departure from the site. The others were asleep in the entrance area, closer to the outside air. The guide was awake, but sitting quietly near the passage. She sat in the chamber with her headlamp turned to its lowest setting. Enough light to see the space, not enough to cancel the cave's own quality of darkness. She had the radiocarbon samples in her bag. She did not yet have the dates, but she had been in enough caves and read enough stratigraphy to understand what the dates were going to say. She was sitting with a knowledge that the world did not yet have in the place where the evidence of that knowledge was preserved, in the cold and the stillness that were identical to the cold and stillness that had preserved it for 28,000 years. She wrote that she thought about the people who had been here. She did not allow herself the abstraction of the professional framework. She thought about specific people, the person who had arranged the flat stones in the oval of the hearth, carrying them from wherever they had been collected, setting them with the particular care that goes into making a thing that will be used. The person who had made the first cut into the mammoth, working with a stone tool on the hide and flesh of an animal that was larger than any vehicle she had ever driven, in the knowledge of what the work provided and the skill that the work required. the people who had slept here with each other in the warmth of the fire, with the cold pressing against every surface that the fire did not touch, looking at the ceiling that she was looking at now. She wrote that she was struck by how unremarkable their presence felt. Not strange, not alien. They were people sitting in a cave keeping warm, which is among the most fundamental and universal of human activities. They had been frightened, probably, had been cold, had been grateful for food, had told each other things that mattered to them, had been, in all the ways that count, fully human, not proto-human or pre-human, or any of the categories that distance ancient peoples from modern ones in ways that are more convenient than accurate. And none of them had known that anyone would ever try to find them. They had not been archiving themselves. They had not been making a record for the future. They had been living. The hearths and the tools and the bones were not evidence that they had intended to leave behind. They were the residue of a life that was complete in itself and that had no reason to anticipate being found. She turned her headlamp off. She sat in the complete darkness of the chamber for several minutes, in the cold, in the oldest occupied space she had ever been in. She wrote that she felt, unexpectedly, something close to peace, not the peace of resolution or completion, the peace of being in the right place, of being, for a few minutes, genuinely present in the depth of time that the cave contained, without the mediation of science or language, or the need to do anything with the experience except have it. Then her headlamp came back on. She wrote her last field notes for the day. She went to sleep. In the morning, they left. The cave stayed. 28,000 years of human presence in a single cave in the Northwest Territories. Evidence preserved in cold and stone through every catastrophe and transformation of the world above. Evidence of people who survived the last glacial maximum, who hunted mammoths in a landscape of ice, who carried fire into darkness and fed themselves and their families in conditions that are almost incomprehensible from the comfort of the present. Evidence of a continuity of human life in what is now Canada that extends so far back into time that it challenges the most basic assumptions of the national story this country tells about itself. The cave is closed. The research continues. The Indigenous peoples whose ancestors lit those fires continue to live on the land where their ancestors lit them, and their relationship to that land is documented now not only in their traditions and their legal arguments and their political claims, but in the genome of the ancient dead, and the charcoal of ancient fires, and the cut marks on the bones of extinct animals. The evidence is real. The history is longer than anyone was ready to believe, and somewhere in the Mackenzie Mountains, in a fold of limestone hillside, in the cold and the dark and the stillness that is not changed, the cave holds everything it has always held. Patient, indifferent to our categories and our timelines and our need to have a story with a beginning, a middle, and an end. Still there, still old, still containing in its frozen archive the oldest chapter of the human story on this land. We are still learning what that chapter says. If this story made you feel the weight of deep time, even a little, even for a moment, then you understand why this channel exists. There is more where this came from. Subscribe. Share with someone who thinks they know Canadian history. Leave a comment. We genuinely read everyone, and the discussion in the comments on these videos is one of the best parts of making them. Next time, we go somewhere else that the standard story leaves out, somewhere else that is older and stranger and more significant than the textbooks had room for. The land remembers. We are trying to catch up. The environment that the WR7 occupants knew 28,000 years ago was not the environment of the contemporary Northwest Territories, and the difference is worth dwelling on because it shapes everything we understand about who those people were and what it took for them to survive in that place. The last glacial. Maximum. The period of maximum ice extent in the Pleistocene, approximately 21,000 to 26,000 years ago, had not yet reached its fullest expression when the oldest WR7 occupation was occurring. But the climate was already shifting dramatically toward the glacial conditions that would eventually see ice sheets covering most of what is now Canada to depths of several kilometers. The Mackenzie Mountains corridor itself, the region where the cave sits, was a complex landscape during this period, neither fully glaciated nor anything like the subarctic terrain of today. It was colder, much colder, with mean annual temperatures that researchers estimate ran approximately 10 to 15 degrees Celsius below modern values. The growing season was minimal. The permafrost was far more extensive than it is today. The vegetation was dominated by species associated with the so-called mammoth steppe, an ecosystem that has no modern analog, a kind of cold, dry, productive grassland parkland that extended across enormous areas of the unglaciated portions of northern North America and Eurasia during the Pleistocene. The mammoth steppe was not a barren wasteland. It was productive. It supported large populations of large animals. Woolly mammoths, steppe bison with horn spans of more than a meter, horses, woolly rhinoceroses, further west, giant ground sloths, short-faced bears, American lions, and the enormous elk moose known as servalses, among many others. The biomass density of the mammoth steppe was, in some estimates, comparable to that of the modern African savanna, an ecosystem famous for the density and diversity of its large mammal fauna. The North in the late Pleistocene was not empty. It was full of life in forms that the modern world cannot quite replicate. For the people who lived in this environment, the people whose fires and tools and food, refuse are preserved in the layers of WR7. This abundance was the context of their existence. They were hunters of large game in a landscape that was abundant with large game. They were cold adapted in a way that their genetics and their technology and their choice of this particular cave, deep enough in the limestone to benefit from the thermal mass of the surrounding rock, suggest was not accidental, but developed over generations of accumulated knowledge about how to survive in conditions that are genuinely extreme. The technology visible in the WR7 assemblage is not spectacular in the way that Clovis technology is sometimes described as spectacular. The Clovis point is a recognized masterpiece of stoneworking, technically demanding to produce, elegant in design, effective in function. The WR7 lithics are simpler, core tools, flakes, scrapers, choppers, basic, functional, produced with skill, but without the elaboration that characterizes some later North American stoneworking traditions. This simplicity is not evidence of a less capable or less intelligent population. It is evidence of a different kind of technological strategy, one that valued versatility and quick production over the investment required for elaborate points. Simple flake tools can be produced quickly from available raw material. In an environment where you are moving frequently, following game across a landscape that demands constant adaptation, a technology that can be reproduced wherever you are may be more valuable than a technology that requires specific materials and extended preparation time. The choice of raw materials in the WR7 assemblage supports this interpretation. The stone used for the tools came from multiple sources, different types of chert and quartzite, whose geological origins have been traced to locations spread across a significant area of the surrounding landscape, some of them more than 100 kilometers from the cave. This pattern of raw material procurement, collecting stone from multiple distant sources rather than relying on a single local source, is consistent with a mobile population covering large areas in their seasonal movements. They brought stone from wherever they found it. They carried it with them. The cave was one node in a movement pattern that covered country. The Mackenzie Valley drainage is one of the great river systems of North America, and its role in the human story of the continent extends far beyond the WR7 discovery. The Mackenzie River itself is the longest river in Canada, more than 4,000 kilometers from its headwaters in the Rocky Mountains to its delta on the Beaufort Sea, and its valley has served as a geographic corridor for human movement and communication for as long as people have been in the region. The river and its tributaries drain an enormous area of the interior Northwest, and the valley provides a natural route between the resources of the northern boreal and subarctic zones and the somewhat more sheltered conditions of the interior. For anyone reconstructing the routes by which people might have moved into North America at various points in the late Pleistocene, the Mackenzie Corridor is one of the most significant geographic features on the continent. The ice-free corridor hypothesis, the idea that people moved from Alaska and the Yukon southward between the Laurentide and Cordilleran ice sheets into the interior of North America, was for decades associated primarily with a route further east through what is now northern Alberta and Saskatchewan, but the Mackenzie Corridor, with its river system providing direction and resources, was increasingly recognized as a possible alternative or additional route. The WR7 discovery, placing people in the corridor during the last glacial maximum or just before it, suggests that the corridor was used much earlier and under much more extreme conditions than the standard model had imagined. The Mackenzie also has direct relevance for Indigenous history in the region. The Mackenzie Valley is the heart of Dene traditional territory. The Dene have been traveling the valley and its tributaries for as long as anyone can demonstrate, using the river system in both directions, upstream and downstream, and developing a detailed, sophisticated knowledge of its character across seasons. The river freezes in winter, becomes a highway. The river breaks up in spring, becomes a barrier, and then a route for boats. The river floods and recedes across summer, depositing sediment and reshaping its banks, and providing access to fish that run its channels. Every aspect of the river's annual cycle is known, has been known for generations, was taught to children alongside everything else that was necessary for survival and flourishing in the northern interior. This knowledge, accumulated across the same time scale that the WR7 occupations document, refined and passed down and built upon across 28,000 years of living in this specific landscape, is one of the most extraordinary human achievements on Earth. It has no monument. It has no inscription. It is not preserved in any archive that the Western Academy built or recognizes. It exists in the people who carry it, in the communities that teach it, in the practices that embody it. The WR7 discovery does not fully reveal this knowledge. Archaeology rarely does. But it establishes the depth of the tradition in which it developed, and that depth is argument enough for treating what that tradition contains with the seriousness it deserves. The academic reception of the WR7 findings was not uniform, and the heterodoxy of responses reflects the genuine complexity of what the evidence requires the discipline to reckon with. The archaeologists most immediately welcoming of the findings were, predictably, those who had spent years advocating for pre-Clovis dates at other sites. For them, WR7 was confirmation of what they had been arguing in the face of institutional resistance, and the response was something close to relief alongside the intellectual satisfaction of a well-documented new site entering the literature. Researchers like David Meltzer, who had written extensively about the Clovis controversy and who had been cautiously open to pre-Clovis evidence for years, responded to the WR7 paper with measured but genuine enthusiasm, acknowledging the quality of the evidence while noting, responsibly, that a single site, however well documented, requires corroboration. The physical anthropology community's response was shaped significantly by the quality of the skeletal material and the ancient DNA findings. The faunal analysis community engaged with the extraordinary Pleistocene megafauna assemblage as much as with the human evidence. The WR7 faunal collection was, in its own right, one of the most significant additions to the North American late Pleistocene record in decades, independent of the human association. The most substantive skeptical engagement came from researchers working on the chronology of the peopling of the Americas, who were not committed to the Clovis first model in its most rigid form, but who were cautious about extending the North American human record as far back as the WR7 dates implied. Their concerns centered on the quality of the stratigraphic documentation and on the question of whether the association between the human artifacts and the dated materials was as unambiguous as the paper claimed. These are fair questions in any archaeological context, and they were addressed in subsequent publications from the WR7 team with the kind of detailed stratigraphic argumentation that takes years to develop from field evidence, and that, when it was eventually published, largely satisfied the skeptics who were engaging in good faith with the evidence. The responses that were least satisfying from a scientific perspective were those that rejected the findings on what amounted to prior commitment grounds. The position that the dates must be wrong because the dates implied something that contradicted the accepted framework, a form of reasoning that is precisely backwards from what scientific inquiry requires. Several such responses appeared in the commentary literature in the year or two after the initial publication, and they were addressed, and the debate moved on, as scientific debates do when the evidence is sufficiently robust. By approximately 2015, the WR7 dates were part of the revised consensus. The revised consensus did not simply add 28,000 years to the beginning of the North American human record while keeping everything else the same. It required a fundamental rethinking of the conditions under which people could survive in the North during the late Pleistocene, of the roots and timing of the initial peopling, of the relationship between different indigenous populations and their common and diverging ancestry, and of the role of refugia, ice-free or marginally habitable pockets within the otherwise glaciated landscape, in maintaining human populations through the maximum glacial conditions. One aspect of the WR7 story that has received less attention than it deserves is the role of the junior researcher, the doctoral student who was part of the original survey team and whose dissertation was, by any measure, transformed by the experience of the initial survey. Her name has appeared in some of the academic literature, though she has chosen to maintain a relatively low public profile, despite the significance of her contribution to the initial survey. She completed her doctorate incorporating the WR7 findings into a dissertation that examined the use of cave sites in the Canadian North as refugia during the last glacial maximum, a question that, before the WR7 discovery, had been largely theoretical, and that the discovery made suddenly and urgently empirical. The dissertation was well received and led directly to a faculty position and a research program that has continued to build on the WR7 findings for more than 2 decades. She has given occasional interviews, always carefully, always with attention to the boundaries that the consultation framework with the indigenous communities has established. In one interview, conducted several years after the initial survey, she said something that has stayed with everyone who has read it. She was asked what the experience of being in WR7 for the first time had been like as a young researcher at the beginning of her career. She said that it had given her a question she would spend the rest of her professional life trying to answer, and that the question was not a scientific question, or not only a scientific question. The question was, how many other places like this are there? How many caves, how many sites, how many landscapes are holding evidence that we have not yet found, have not yet been led to by the people who know where to look? How much of the true story of human presence on this continent is still waiting to be found, in cold archives maintained by the land itself, patient in the way that evidence is always patient with the investigators who have not yet arrived? She said she did not know the answer. She thought it was a large number. She thought the WR7 discovery was not the exception, but the example, the case that demonstrated what was possible, that showed what careful fieldwork conducted in genuine partnership with Indigenous knowledge holders could find when the conditions were right. She thought the North was full of archives. She thought the work of finding them was only beginning. The broader context of the WR7 discovery within the global science of ancient human migration is worth articulating, because the cave does not exist in isolation from a worldwide conversation about human origins and movement that has been ongoing for decades, and that has been radically transformed by the development of ancient DNA analysis. The story of how Homo sapiens spread across the planet from its origins in Africa is now understood with a granularity and a complexity that would have seemed impossible to researchers working only a generation ago. Ancient DNA from sites across Europe, Asia, the Americas, and increasingly Africa has produced a picture of human prehistory that is far more complex than the simple replacement models that once dominated the field. There were multiple migrations. There were multiple waves of movement across different routes at different times. There were encounters between populations, some violent, some apparently not, that left genetic signatures in the descendants of both groups. The modern human genome is a palimpsest of all these movements and encounters, and decoding it has produced a history of our species that is simultaneously more specific and more complicated than anything the physical evidence alone had been able to suggest. The Americas represent a specific chapter in this global story, the last major continental landmass to be reached by Homo sapiens, at the end of a long process of geographic expansion that had already taken the species across most of the Old World. The question of when and how and through what routes people first arrived in the Western Hemisphere has been one of the most contested in all of human prehistory, and the WR7 discovery is one of the most significant pieces of evidence contributing to its eventual resolution, a resolution that, like all resolutions in science, is not an ending but a new, more complex set of questions. The genetic evidence from WR7 connects to evidence from sites across the Americas in ways that are still being fully understood. The deep divergence between the WR7 lineage and the ancestral Clovis populations is consistent with a model of multiple independent entries into the Americas at different times, producing founding populations that developed in relative isolation before later contact and mixing. This model, sometimes called the two or more wave model in contrast to the single wave model implied by the original Clovis hypothesis, is now supported by genetic evidence from multiple ancient and modern populations across North and South America. The WR7 ancient genomes are among the oldest and most complete data points in this emerging picture, and they will continue to be analytically important as more ancient DNA from other sites is added to the dataset. The full implications of this picture for indigenous identity, history, and legal standing in the Americas are still being worked out in both academic and political contexts. The genetic evidence is complex enough that it cannot be appropriated for any simple political narrative. It does not support claims that any particular contemporary indigenous population is or is not descended from any particular ancient population in ways that could be weaponized in either direction by those who wish to use science to settle political questions that are ultimately ethical and political rather than empirical. Indigenous peoples' connection to the land of the Americas is not contingent on the specific details of migration timing. It is grounded in continuous presence, in cultural tradition, in law, and in the basic human fact of belonging to a place. The science adds depth to that connection. It does not establish or invalidate it. The winters in the Northwest Territories are among the most extreme experienced by any populated region on Earth. The temperatures in January regularly fall below minus 40 Celsius, a threshold at which the Celsius and Fahrenheit scales converge, at which exposed skin freezes in minutes, at which the moisture in exhaled breath freezes before it has fully left the body, at which machinery fails and materials that behave normally in temperate conditions become brittle and unreliable. People who have lived through NWT winters describe them not merely as cold, but as a fundamentally different physical environment, one in which the relationship between the human body and the surrounding world is organized differently, in which the priorities that govern daily life are rearranged around the central fact of heat. The people who occupied WR7 28,000 years ago faced winters that were significantly colder than the contemporary NWT winter, perhaps 10 to 15 degrees colder on average, meaning January temperatures that could approach minus 50 or minus 55 Celsius in cold snaps. They had no synthetic insulation, no electric heat, no fossil fuel infrastructure. They had fire, animal hides, accumulated knowledge, and each other. The cave, with its thermal mass and its relative protection from wind, was a resource in the most fundamental sense, a warm place in a world where warmth was survival. The skill required to survive at those temperatures, using only the technology available to late Pleistocene hunter-gatherers, is extraordinary. It requires detailed knowledge of every animal whose hide can be used for clothing and shelter, and knowledge of how to process those hides into forms that provide insulation without adding prohibitive weight. It requires knowledge of fire making that is reliable, even in extreme cold, with wet materials, with numb fingers, under conditions where failure is not an inconvenience, but a death sentence. It requires knowledge of food that is dense enough in calories and fat to sustain the additional metabolic load of maintaining body temperature in extreme cold. It requires knowledge of shelter, of movement, of the specific locations where these resources can be found, and at what times of year. This knowledge is not instinctive. It is not genetic. It is learned and transmitted, taught by one generation to the next, in a process that requires time and patience and specific environments in which teaching can occur. It accumulates over generations. What works is kept, refined, elaborated. What fails, often catastrophically, is eliminated from the tradition. The body of cold weather knowledge that the WR7 occupants would have possessed after thousands of years of accumulated refinement was a sophisticated technical and ecological knowledge base, comparable in its depth and precision to any other human knowledge tradition. It simply left fewer physical traces than the traditions that produced monuments or manuscripts. The cave is, in part, a monument, not to the dead, not deliberately, but the fact of its use, the deliberate creation of fire features, the processing of large animals, the apparent repeated return to the same location over many generations, is evidence of a tradition that was transmitted successfully across deep time. Someone taught someone else that this cave was here, and how to use it, and why it was worth the effort of reaching it. That teaching was received and passed on and received again across spans of time that are almost impossible to feel. The guide gave only one formal interview about the WR7 discovery, published in a regional newspaper whose archives have been digitized and that can be accessed online, though it is not widely cited in the academic literature for the obvious reason that regional newspaper interviews are not standard academic sources. It is worth considering what he said in more detail than is usually devoted to it. He was asked first about his grandfather's description of the cave. He said that his grandfather had not made a mystery of it. He had described it as a place where the old people had been, and where the old animals had been, and where it was not wise to go without thinking about why you were going. This did not mean prohibited. His grandfather was not given to prohibitions for their own sake. It meant that the cave was a place where you should know your intention before entering, the way you should know your intention in any situation that has consequences. You do not go into a place like that to entertain yourself. He was asked what he thought when he first saw what the researchers were documenting. He paused before answering, the journalist noted, and then he said that he had not been surprised in the way they seemed to expect. He had known the cave was old. He had known it in the way you know things that you were taught before you were old enough to question them, before the question of whether to believe them had occurred to you. What he felt was more like recognition than surprise. The researchers were finding the shape of something he had already known was there. He was asked about the closure of the site and his feelings about it. He said the cave had been there for 28,000 years, according to the scientists, and that the government's closure order was not likely to be the thing that finally changed it. He said the closure was probably right. The cave did not need visitors. It had always been a working place, a shelter, a location, with a specific purpose. Turning it into a place for people to come and look at things seemed like the wrong kind of attention. He said his grandfather would have agreed. He was asked finally what the discovery meant to him personally, not as a community member or a cultural knowledge holder, but as a man. He thought for a longer time before answering this one. Then he said that it had made him feel less alone in a particular way that he did not know how to explain better. He said that when you are part of a small community in a very large landscape, and the world outside your community has been telling you, directly and indirectly, for as long as you can remember, that your presence in this landscape is relatively recent and somewhat contingent, and certainly secondary to the claims of the institutions and governments that arrived later, when you have absorbed that message in 100 ways across a lifetime. The discovery that your ancestors were here so long ago that the language of the word ago becomes almost meaningless, that this place has been your place for longer than any other human beings have been anywhere in the Americas, that the connection you feel to this land has a depth and a continuity that no document and no government decision has ever been able to extinguish. That means something. He said it meant something that he found difficult to say in English. He said it in his own language, to himself, and did not translate it. The journalist noted this without comment. It seems like the right way to end his part of the story, with something that belongs to the language and the tradition and the people it came from, not translated into the categories of the outside world. End script echo, appended additional sections, WC, W, home, Claude, cave, script, V2.MD. The question of what happened to the WR7 population, the people who occupied the cave in its deepest and most ancient layers, is one of the questions that the genetic evidence has only partially answered and that remains a productive area of inquiry. The last glacial maximum, which followed the oldest occupation horizon by only a few thousand years in geological terms, was a genuinely catastrophic event in terms of its impact on terrestrial ecosystems and the populations that depended on them. Ice sheets kilometers thick covered most of Canada. The mammoth steppe contracted dramatically as the climate shifted. The animals that had sustained human populations across the far north were either adapting, migrating, or beginning the long decline toward extinction that would eventually eliminate most of the Pleistocene megafauna. The refugia, the pockets of habitable land within or adjacent to the ice, were real, but they were constrained, and the populations that survived in them were subject to the genetic bottlenecks that come from small, isolated groups in difficult conditions. The genetic evidence from WR7 shows that the lineage represented by the oldest individuals was not simply wiped out during the glacial maximum. Elements of that lineage appear in the genomes of later populations, including contemporary ones. This suggests a story of survival. Perhaps in the cave itself, perhaps in related refugia in the region, followed by expansion and eventual merging with other populations as the ice retreated and the landscape opened up again. The WR7 cave may have been one of the nodes of survival across the glacial maximum, a place where a small population maintained itself through conditions that eliminated most of the populations around them. This kind of survival is not passive. It is not luck, or not only luck. It is the application of accumulated knowledge, the knowledge of fire and shelter and food and movement, to conditions that are genuinely testing. The populations that made it through the last glacial maximum in the Canadian North did so because they knew how to live there, because they had been living there long enough before the maximum to have built up the knowledge and the adaptive traditions that made survival possible. The cave was part of that survival apparatus, warm enough, sheltered enough, known well enough to be returned to across the worst conditions the climate produced. The continuity between the ancient WR7 lineage and contemporary Indigenous populations is not a guarantee that the same specific people occupied the cave continuously. There were almost certainly gaps, periods when the cave was abandoned and later rediscovered, periods when populations moved away and others moved in. The genetic continuity is a population-level continuity, not an unbroken family tree from one specific grandmother to another, but population-level continuity over 28,000 years in the same region, with a genetic signal that connects ancient individuals to contemporary communities, is still a remarkable and meaningful form of persistence. The people are still here. They were always here. The cave holds the evidence of how long. The methodology of the excavations at WR7, refined over more than 2 decades of research seasons, has itself become a contribution to the discipline, an example of how to conduct long-term, large-scale cave excavation in a cold climate environment under a joint scientific and Indigenous community framework. The excavation grid is established at the beginning of each field season and maintained with reference to permanent benchmarks set into the cave walls. The grid divides the excavation area into 1 meter by 1 meter units, each of which is excavated by a dedicated team of 2 researchers working in close coordination. The excavation proceeds in arbitrary 10-centimeter levels within each natural stratigraphic unit, with the stratigraphy guiding the level boundaries so that occupation horizons are not inadvertently blended with the deposits above and below them. All sediment removed from the excavation units is processed through a flotation system, a water-based method for separating light organic material, including charcoal, seeds, and small bone fragments, from the surrounding matrix. The flotation residue is collected, dried, and sorted under magnification, producing information about botanical material and microfaunal remains that direct excavation alone would miss. The heavy fraction, the stones and larger bone fragments, is also sorted and analyzed. Nothing is discarded without examination. Every significant find, every stone artifact, every piece of bone larger than 2 centimeters, every charcoal concentration, is plotted in 3 dimensions before removal, using a total station surveying instrument that records horizontal position to within a millimeter and vertical position to within a few millimeters. The result is a spatial database of the entire excavated deposit, allowing researchers to visualize the distribution of material in 3 dimensions and to identify patterns, clusters of activity, differences in the density and character of material across the floor that would be invisible from the deposits alone. The attention to spatial relationships is not pedantic. The spatial distribution of material within an archaeological site contains information about human behavior that the material itself cannot provide. A concentration of cut-marked bone near a fire feature is not the same evidence as the same bone scattered randomly across the floor. A cluster of stoneworking debris in one corner of the chamber suggests a different behavioral pattern than the same debris distributed evenly throughout the space. The spatial data from WR7, accumulated across many field seasons and thousands of plotted finds, has produced a picture of how the cave was used across its various occupation episodes that is far more detailed and behaviorally informative than the dates and the bones alone could provide. The Indigenous members of the research team have contributed to the interpretive process in ways that go beyond the formal scientific analysis. Knowledge of how people move through and use enclosed spaces in the north, of the practical logic of shelter construction and food processing and fire maintenance in cold conditions, of the specific behaviors that the archaeological record is trying to reconstruct from its physical traces. This kind of embodied practical knowledge enriches the interpretation in ways that the conventional academic framework does not have adequate tools to capture or credit. The joint research model is not simply an ethical requirement, it is an epistemological improvement. The publication record from WR7, spanning now more than 15 years of peer-reviewed output from the joint research team, represents one of the most substantial bodies of literature ever produced from a single Canadian archaeological site. The papers address chronology, faunal analysis, lithic technology, spatial analysis, paleo-environmental reconstruction, and the ancient genomics of the human remains. They have been cited hundreds of times in the broader literature on North American prehistory and on the methodology of cold climate cave excavation. They have changed the field in measurable ways, but the impact of the discovery extends beyond the academic literature in ways that are harder to measure, but perhaps more important. The revised understanding of North American human antiquity has worked its way into how the history of the continent is taught at the university level, into the revised interpretation programs at national historic sites across Canada, into the policy frameworks governing archaeological resource management in the territories and provinces, and into the legal arguments made in Indigenous land rights cases, where the depth of continuous human presence in a region is a relevant consideration in the assessment of territorial claims. The legal implications are worth careful attention because they are the dimension of the WR7 story most likely to produce ongoing institutional resistance, even in the absence of any explicit conspiracy to suppress the findings. Land rights litigation in Canada often turns, in part, on questions of historical occupation. Who was present in a given territory, for how long, and with what degree of continuity? The standard of proof required for Indigenous territorial claims is high, and the evidence used to establish it historically has been limited to documents and archaeological surveys conducted within the relatively recent past. The WR7 findings establish, for the specific region of the Mackenzie Mountains corridor, a standard of evidential depth that the legal framework for Indigenous title had never previously been required to reckon with. Not just centuries of occupation, not just millennia, tens of millennia, a span of human presence that predates every other documented human settlement in the Americas by a significant margin, and that extends back to a time before the land itself had its current physical form. This does not resolve the land rights questions that are live political issues in the Northwest Territories today. Law is not simply a function of facts, it is also a function of the institutional frameworks that interpret and apply facts, frameworks that were built by and for specific interests, and that do not update automatically when new evidence arrives. But it changes the context, it changes the terms of the argument. It makes the claim that indigenous peoples are in some sense newcomers to the land, a claim that has never been accurately made and that has nonetheless been allowed to organize too much of the political and legal discussion about indigenous rights in this country. Definitively, irreversibly, empirically unsustainable. The cave closed and its secrets began to emerge. The land is older than the country. The people are older than the land's newest names. The evidence is there, frozen in limestone, waiting for the next question and the patience to hear the answer. The seasons change in the Northwest Territories in ways that are dramatic enough to seem almost theatrical, as if the land is making a point about the distance between what it is capable of being and what it usually presents to outside observers. Summer, when it comes, is extravagant. Long days of full sun, temperatures that can reach the mid-20s, rivers running with snowmelt, and the boreal forest releasing the particular smell of spruce and bog and moving water that people who have spent time in the north describe as one of the most distinctive scents on earth. The mosquitoes and black flies emerge in clouds that are not metaphorical, clouds in the literal sense, dense enough in some areas to be visible from a distance, dense enough to make unprotected outdoor work genuinely uncomfortable. The animals are everywhere, moose in the river shallows, caribou, moving across the tundra in herds that can still number in the thousands, birds arriving from their southern wintering grounds to breed in the long northern days. The land, which in winter seems to have compressed and simplified itself into an austere geometry of white and gray and the dark lines of trees, expands in summer into an almost bewildering richness. This richness was the reward for enduring the winters. The people who occupied WR7 28,000 years ago would have known the full cycle, the terrifying cold, the return of light, the explosion of abundance, and the slow withdrawal again toward darkness. They would have organized their lives around that cycle in ways that required intimate knowledge of its timing, its variations, its reliable patterns, and its surprises. They would have known which rivers ran clear and which ran silty, and what that meant for fishing. They would have known the routes that the caribou followed in their seasonal migrations, and the specific locations where the herds could be intercepted. They would have known the plants whose roots were edible in early spring when the winter stores were depleted. They would have known, in the most immediate and practical sense possible, that this land was their home, not a territory they occupied, but a place they knew, a place that sustained them, a place that they understood well enough to survive in through conditions that most of the world's human populations in their time could not have imagined. The cave was part of that home, part of the geography of survival that constituted the world they lived in. They left and returned, and left again and returned for so long that the leaving and returning became part of the tradition that their descendants carried forward, became the knowledge that the cave was there, that it was old, that it mattered. 28,000 years later, a geologist from the University of Alberta sat alone in the dark in that same space and felt the weight of all that time pressing around her, and found it, despite everything, peaceful. That peace is deeply earned. It is the peace of a story that is longer than most of us know how to hold in mind, longer than the categories of the world we were given allow us to fully feel. But it is available if you are willing to sit quietly with the evidence of deep time and let it do what evidence does. Change the way you see. The cave is closed. The story is open. We are still inside it. The research continues in seasons. The ice holds. The bones wait in the dark for the questions we have not yet learned to ask, questions that future researchers, some of them descendants of the people who first sat by those ancient fires, will bring to the cave with instruments we cannot yet imagine, to learn things about the deep human past that we cannot yet conceive. The archive is patient. The work is not finished. It has barely begun.